Hello, my name is Tyler Vanderwall, and this is my presentation for the PLC project that I've been working on. It is two POUs and one PLC. One is for a component cooling system, and the other is for a wastewater management system. On the screen right now is the HMI for the component cooling system. I'm going to run through how it works and then go into the code afterwards. So of course, there's the master control. So here, you turn it on and the system on light comes on. Now, unfortunately, CodeSys does not have a three-position selector switch function in the HMI, so you can only choose one of these, but instead of having the three-position selector switch, there are just three switches, and I had to interlock them so that way the system cannot run if more than one of them is on at the same time. The modes are automatic, which cycles through pump 1 and pump 2, or pump 1 or pump 2, which just turns on their respective pumps. So, for example, pump 1, fan 1 comes on. Fan 1 is always on as long as one of the pumps are running. If I try to turn on pump 2, everything shuts off. Only because only one can be on at any given point. If I go through automatic, they will cycle every 15 seconds, so I will leave that on so you can see. Fan 1, as I said, is always on. Fan 2 comes on when the temperature is above 100 for 15 seconds, 100 degrees Fahrenheit, and this is just to simulate the temperature right here. Fan 3 turns on as long as the temperature is above 150 degrees Fahrenheit, and fan 4 turns on if it is above that temperature for 15 seconds. So, of course, we're going to let that run through. These are the overloads. If one of the overloads turn on, it will automatically turn the other pump on if it's in automatic mode. Right now, pump 2 is on. If I turn on the overload, it goes to pump 1, even though it's before the time, as you can see. And if pump 1 is on, pump 2 will just stay on. The pump 1 overload, I mean. Then there are overload indicators here. If, say, pump 1 is on, let me turn the temperature back down, and I turn on the pump 1 overload, pump 2 does not come on. If it is just supposed to be running pump 1, that is something that only happens in automatic mode. Because you wouldn't want a pump to be running when you have specifically selected pump 1 in case there's an issue with pump 2, and that's why you selected only pump 1 to run. So that is the basics of how that system runs, and now I'm going to go through the code. I've done it in function block, and let's start at the top. This, I have it's basically three-wire control, but in function block. And I have this system off here. The only thing that does is control the system off light, whether it's on or off. And here are the timers. These timers, timer 1 and timer 2, cycle back and forth between each other when automatic mode is on, as you can see. It requires pump 1 select and pump 2 select to both not be on because it's an automatic mode function. When this timer is running during automatic mode, pump 1 is on. When this timer is running during automatic mode, pump 2 is on. And that's all that these two networks are doing. This is just the requirements for pump 1 to be on. Either it's in automatic mode and the timer 1 is going, or I have pump 1 select is on and the system is running, or it's in automatic mode and the pump 2 overload is on and the pump 1 overload is not on. That is the requirements for pump 1, and then here I have that basically copied for pump 2 because they work the same. Next is the fans. Fan 1 is always on as long as one pump is on. And this section here, these 3 ands tied into an OR block, is because CodeSys does not allow for 3-position selector switches. I had to interlock these modes so that way none of the fans or the pumps run if more than one mode is selected at the same time. And I originally was going to do that with an XOR block, but XORs in CodeSys do not work with 3 inputs. It has to do with how they work. They are an odd number parity, so as long as there is an odd number of inputs activated, it will send a signal. So when you have 3 inputs and they're all on, it sees that as an odd number, and even though it's supposed to be an exclusive OR, it will still send a signal. So instead of using an XOR, I had to use 3 AND blocks to interlock the modes. And you'll see that with all of the fans here. They all have that. Fan 2, of course, runs on a timer as long as the temperature is above 100 degrees Fahrenheit for 15 seconds. And the system has to be on, of course. And fan 3 and fan 4 both work around 150 degrees Fahrenheit, the only difference being fan 3 turns on automatically and fan 4 after 15 seconds. And then here's just the overloads. So that's the code for how the component cooling system works. I'm now going to go into the wastewater transportation. There are 2 tanks. The first tank has 1 pump, and once it reaches a high level, pump 1 turns on, and it stays on until it reaches the low level sensor, in which case it turns off. I added a little bit of extra functionality so that if it reaches the high level and the overload turns on, once the overload turns off, pump 1 still stays on until it reaches the low level, or else it would have to reach the high level sensor again in order to turn on, and that might not be good. So if I turn the overload on and then somehow it hits a low level and then the overload turns off, it will not turn on. I'll go through how I did that in the code afterwards. The other tank, because tank 1 pumps into tank 2, the other tank works with 3 different pumps. Once it reaches a certain point, pump 2, which is the first tank in the first pump in the second tank, will turn on. After 15 seconds, it will turn on to its high speed. After 15 more seconds, it will turn on pump 3 low speed, and then pump 3 high speed, pump 4 low, and pump 4 high. Those are all cascaded within 15 seconds. And it's set so that if this turns off at any time and it reaches the low level and comes back again, it resets. Now, the rest of the code for this is functionality that I added in because I thought it would be necessary in a real world environment. If the overload for pump 2 turns on, it will automatically turn on pump 3. If the overload for pump 3 is also on, it will turn on pump 4. If 3 is on but 2 is not, it will choose 2 because that's the lowest pump. As you can see, it works with pump 3 as well. This is because in a real world environment, if only pump 2 is supposed to run but the overload is on, you still need a pump to run. So it would just switch it over to the next pump until the one with the overload on is fixed. So that's the functionality that I added. And of course, if they're all going, there's no extra pump to run. So if they're all going and an overload turns on, it will just simply shut off. That's not ideal, but there's no other way we could get past that without adding another pump. And after 15 seconds of them all being on, the tank 2 overflow light or alarm or however you choose will turn on. And of course, these pumps stay on even if the overflow is on because it still needs to pump out. If the pump's turned off, then the overflow would get worse, obviously. So I will go into the code for that now, which I did with ladder logic. All right, so I did 2 separate 3-wire controls for tank 1, and that's how I achieved the functionality with the overload. Originally, I had just pump 1 as the coil and then pump 1 here as its own holding contact. But then when the overload would turn on, it would turn off pump 1, which means it would also turn off the holding contact. So when the overload turned back off, pump 1 would not run because it would be shut off already. I got past this by doing a separate 3-wire control just for the holding contact, so that when this holding contact comes on, it does not get shut off by this overload, so that when the overload gets fixed, it sends signal through automatically until it hits the low level. That was my thought process there. The bulk of the rest of the code is just this rung here, rung 3. It works off of course, the float switch in tank 2, which is what determines if the system is running or not. If the pumps in tank 2, I mean. And it's a little bit confusing to look at. Pump 2, they all have overloads like before them, so that if it's overloaded, they can't run, obviously, because that would be bad. Uh, so here is pump 2 turning on automatically. The high level for pump 2, or high speed rather, turning on after 15 seconds. The low level for pump 3 turning on after 30 seconds, and then 45, 60, 75, and then for the overflow, alarm, or light, or whatever you choose after 90 seconds of this system being on. So I have some extra functionality here, and that's just for the overloads when one pump switches to another. For example, the pump 3 high speed actually has a couple different requirements to be on. It can either turn on after 45 seconds has elapsed, or after 15 seconds has elapsed and pump 2 is overloaded. That's because if we go back here, pump 3 can either, the high speed for pump 3 normally would be after 15, 30, 45 seconds. Or if it goes right to pump 2 after 15 seconds, but pump 2 is overloaded, it will switch over to pump 3. So that is the thought process there. And it works the same for the rest of them. Like the high speed for pump 4, for example, either will turn on after 75 seconds normally, or after 15 seconds if both pump 2 and pump 3 are overloaded, or after 45 seconds if pump 3 or pump 2 are overloaded. There's a slight difference there because if it's 15 seconds, then both of them need to be overloaded for it to go all the way to 4. But if it's after 45 seconds and pump 3 overloads, it will switch over to pump 4. But if pump 3 doesn't overload, it will run as normal. And pump 2 overloads, pump 2 cannot switch over to pump 3 because pump 3 is already running, so it would have to switch over to pump 4. That's the thought process there. And then the rest of them are just the overloads, the overload functionality. That is the entire project of the 2 POUs for the different systems and how they work. Let me turn this off. Okay. Thank you for your time and attention. I hope you enjoyed.